Hello friends, welcome back to my channel Chemistry with DB. In the last two videos on aromatics series, the first and second, I had explained the Kekulé model for benzene. In the second video I explained as to how the Kekulé model was disproved. And now what's the current structure and bonding for benzene, which is a regularly asked question in the A-level question papers. So now we all know that the 6 carbon atoms in case of benzene are arranged in a hexagon, and it is a simple molecular structure. It's not a lattice, it's a simple molecular structure. Each carbon atom is bonded to 2 carbons and 1 hydrogen, and because each carbon has 4 electrons, so 3 electrons are occupied in the 3 covalent bonds. So the fourth electron on each carbon, which is free, it's in a p orbital, and p orbitals are dumbbell shaped. So this is the p orbital on this carbon, here is the p orbital on this one. So all of these p orbitals undergo a sideways overlap with each other. As a result of this, what happens is that you get a electron cloud spread like a ring. So this is above and under. So above and below the hexagon, this is the delocalized electron cloud, which is known as the pi system. Pi system, and so there are no pi bonds in case of benzene, mind you. It's a pi system of delocalized electrons. In order to give you some notes, I have laid down. It's a simple molecular structure. It's a flat molecule because of the trigonal planar arrangement, cyclic hexagonal. HCC bond angle, this one, the HCC, each of this bond angle is 120 degree, like in case of any other trigonal planar arrangement. And each carbon is covalently bonded to 2 carbons and 1 hydrogen atom, and the fourth electron in a p orbital, which is dumbbell shaped, it undergoes sideways overlap with the other p orbitals, and this gives rise to a pi system of delocalized electrons. All of the CC bonds are of the same length, right? And there are no CC or C double bond C present. Now, how do we explain the lack of reactivity? Because of the delocalization of these 6 electrons over a large hexagon, the electron density is poor, and as a result, it's unable to induce dipoles in a nonpolar chlorine or bromine molecule, and also it's unable to attract electrophiles sufficiently enough on their own without a catalyst or without a halogen carrier. And that explains as to why benzene is much less reactive as compared to alkenes. So I hope this you were able to understand the current model of benzene, and the notes I have also given to you. So I hope this was useful, and in case you like it, then please like, share and subscribe, and I look forward to see you on my next videos on aromatics only. So bye and take care.